Hi, everybody. This is Mrs. Wolf. So sorry I couldn't be there with you guys again today. You may have seen me around the building already. I am in the building. I'm actually subbing for Miss Rosenbrock today. So I am the dean. You will see me out and about, hopefully. But you do have some notes to take today in science. So I wanted to run through the notes with you since we are starting a brand new packet. This is our Unit 2 on cell structure and function. So hopefully you already went ahead and you set a goal. You looked at that list of vocabulary. And then you also watched that little introduction to cell theory. So Unit 2 is our first unit on cells. We have six whole units on cells. So almost the whole year is spent studying cells, and today is day one, and we're going to talk about something called cell theory. So as you watched on that little video, cell theory is really something I like to think about in terms of like a story. So this is the history of scientists that have been given credit for contributing to the ideas about cells and what we know about cells today. So we'll go through, I think there's 5 scientists that we'll talk about. And yes, you are responsible for remembering who they are, what order they came in history, and what contributions they gave to science. So, what did they do and what ideas did they share that we may or may not still believe to be true today? So, let's start with Robert Hooke. We have 2 guys that have the name Hooke, right? We have Hooke and Leeuwenhoek. So when we're trying to remember these guys in order, these are my 2 Hooke guys. And the first Hooke here on the left-hand side is Robert Hooke. You should be writing down the word cell. So as I go through the story as well, I also want to highlight a couple key words. Let me see if I'm annotating here correctly. So you're writing down cell and you're writing down animalcules, right? As we try to memorize the scientist and what they contributed to the cell theory, I also want you to circle and kind of make note of particular words that are going to help you remember about each of these scientists. So here, Robert Hooke was one of the first scientists to look at cork in particular. So if you think about like a wine bottle with a cork in the top, that's what we're talking about when we say cork. Cork actually comes from trees. So what Robert Hooke did is he took very thin slices of this cork and he put it under a microscope. What he saw was this little honeycomb looking thing, like these little empty vessels, I guess you can say. It kind of looks like honeycomb to me. And he really didn't know what he was looking at just yet, but he called these cells. So that was like the very start of our idea of what a cell is and what we know a cell to be today. So Robert Hooke is given credit for studying cork. I want you to think of the word cork, and then also one of the first scientists to use the word cell. So this is happening in the 1600s, right around the same time Anton von Leeuwenhoek is doing studies with a microscope as well. You saw in the video his microscope is very different looking from what we think a microscope to look like today. His looked more like a paddle, and they kind of made fun of it in the video that it looked like sunglasses if you put 2 side by side. And what did he study? You probably remember the odd thing that Leeuwenhoek put underneath the microscope. Yes, you're thinking? Teeth gunk. Tooth gunk. So I want you to write that down in your notes. So anything that I'm writing here on the screen, make sure that you're including in your notes because these are little tips and tricks to help you remember all of these scientists. So he was studying his teeth gunk, and as he looked under the microscope, he saw all these little moving organisms. We know now that we've done a couple units here in science, we know that those single cell organisms, we call those unicellular. He just saw little moving things, little organisms. He didn't know what to call them, so he gave them the name animalcules. What he was actually looking at is bacteria, single-celled unicellular organisms that have everything they need to be considered living, right? Shows all 6 characteristics of life. So tooth gunk, your mouth is full of bacteria. So if you were to do the same thing, you would see little moving organisms, not animalcules, because we know that not to be a word anymore, but we know them to be bacteria. So when you think of Hooke, I want you to think of cork. I want you to think of the cell. And for Leeuwenhoek, you're thinking about his tooth gunk examination under the microscope. and that he was looking at animalcules and bacteria. Well, bacteria that he called animalcules, right? Okay, let's look at the next slide here. So then there was a period of time after Leeuwenhoek where really no new discoveries were made and no additional contributions to science in terms of what they knew about the cell. It kind of paused for a long period of time. So during the 18th century, um, as new ideas weren't necessarily arising in terms of what we knew about the cell, there was this idea about something called spontaneous generation. And you're writing the word generation in your notes. I think that's the only thing you're writing there. But let's talk about spontaneous generation for a minute. So if you think about the word spontaneous, so spontaneous means happening suddenly, kind of without warning, all of a sudden. So there was this idea in the 1800s that kind of divided the world of scientists. Some scientists were believing that spontaneous generation is a true thing. They thought that cells could just appear out of nowhere. Life could just, ta-da, there it is, right? That's spontaneous generation. We know spontaneous generation to be false. This is not true. Cells and living things just don't appear out of nowhere. They don't spontaneously all of a sudden just, they're there, right? So some scientists believe that to be true. They thought life could come from nothing, could just arise from non-living things. The other scientists believed, well, really disagreed with spontaneous generation, but agreed and believed that living things and cells must arise from something that's already living. They can't just appear. So, in order to kind of test this hypothesis, what happened in the 1800s is that scientists put together this study using meat, we know to be dead, right? We classify that meat to be dead. And wanted to see if life or cells would spontaneously appear out of something dead, like a piece of meat. Do flies really come from dead meat? Is that how that works? So that's what they were testing. So they had three different setups here. You can see they have a sealed jar with the meat in the jar. They have a gauze covered jar, which is kind of like, you want to think of gauze as maybe like a tissue material where air can pass through it, but organisms wouldn't necessarily pass through it. So kind of just air can pass through that. So they covered the jar with a piece of gauze. And then the last one, they had a wide open jar. And what they observed is, you can see all the way on the right-hand side that wide open jar suddenly has flies and flying around, and you can even see like some little maggots. Those are those little white gross worms, the larvae form of flies. So when the jar is open, flies are able to come to the jar, right? Because the meat would be the food source for them. So they're going to flock to and just appear around, kind of like trash, right? If you have trash outside, flies are going to be attracted to that. So they were able to observe that. And next to it, in the gauze covered jar, they noticed that the flies were able to be attracted to the jar, just like in the open jar situation, but they were only at the top of the jar. None of the flies were inside the jar. Okay, so now let's compare that to the very last one where no flies, no larvae, no life is appearing inside of the jar. So if spontaneous generation was true and living things can just spontaneously arise from dead material or from non-living things, you would be finding, let's see if I can draw, that's a fly, it looks like a butterfly. You would be finding flies in the jar, but that's not the case. They didn't find any flies inside the jar. So what this really did is it disproved, or it showed, that spontaneous generation is not true. Cells and living things don't just appear out of nowhere. Okay, so we moved past the 1800 and we have this idea of spontaneous generation and the test that was used to disprove spontaneous generation. Let's get back to, we'll come back to this idea. We'll see this idea in the cell theory, the three tenets of cell theory, the three pieces that make up the cell theory here in just a little bit. But let's continue our journey through the timeline of scientists that contributed to cell theory and to our knowledge about cells. So, again, we had Hooke. He was the cork person. He looked at cork under the microscope and used the word cells for the first time, followed by Leeuwenhoek, who examined his tooth gunk underneath the microscope and observed bacteria and named those animalcules. And then our next two people I remember as both starting with S. So our two S scientists, we have Schleiden, followed by Schwann on the next slide here. But Schleiden in the 1800s, after that whole 100 years of kind of a pause in cell discoveries, Schleiden was a botanist, so he studied plants, and he began taking samples of his plants, little shavings, I guess, thin layers of his plants, and putting it underneath the microscope. He would look at the leaves and the stems and the roots and the petals and all the pieces of the flowers, all different types of flowers and plants. And he noticed they were all made of cells. So he's the plant guy. I refer to Schleiden as the plant guy, the botanist. And to us, it seems pretty obvious, and we've already talked about that all living things are made of cells. That's a characteristic of life. So we already know that plants are made of cells. But in the 1800s, that was a big thing. That was a big discovery. So Schleiden has been given credit as being the one to discover that all plants are made up of cells. So that's his contribution to our understanding. Okay, let me erase that. So on the next slide, go ahead and turn to slide 4. Take a look at slide 4 here. Continuing our journey, we're looking at Theodor Schwann, also in the 1800s. And Schwann, I always think of the word swan because he has been given credit for discovering that all animals are made of cells. So very similar to Schleiden, right? Schleiden said that all plants are made of cells. Schwann made a very similar discovery as he started looking at tissues of animals. He noticed that all of the animals are also made of cells. So because a swan is an animal, Schwann and swan, right? So when I think of Schwann, I think of animals, and he is the discoverer of animals being made of cells. So that's 4 of our scientists. Hopefully my little tips and tricks are helping you out there. We just have a couple more slides here before you guys give it a try on your own. Let's look at Virchow. He's a German physician, or was a German physician from the 1800s. He proposed the idea that all living things, or the idea that all living cells must arise from pre-existing cells. So I want you to circle the word pre-existing. When I think of Virchow, I think of pre-existing cells. It's kind of a common term that they use to describe that all cells come from other cells. When we think about spontaneous generation, right? A couple slides back, the scientists were split between, do cells come from cells, or do cells come from thin air, or like they had those two differing ideas, right? So Virchow finally came to the conclusion with some additional experimentation that all cells don't just spontaneously generate, but they do in fact come from pre-existing cells. So all cells come from cells that were already living, already there, right? That's what pre-existing means. So all cells come from pre-existing cells. We'll hear that again because that's actually one of the tenets that'll go into our cell theory. Okay. That was such a profound idea that it becomes the third tenet in the cell theory, which we still believe to be true today. All right. Sorry, doing some clicking here. Okay, so let's put a big star on this one. We know what my stars mean, right? Star means you're going to see this again. So I really like this slide. I like a good conclusion slide that wraps up everything that we just talked about in that timeline. So let's review the scientists that studied cells. Starting with Hooke. Hopefully you think of the word, you're thinking it, cork. So write down the word cork underneath hook. We're just going to go through these guys and write down the key words and the key concepts that help you remember, hopefully, all of them in order and what they contributed. So we have hook. He contributed by looking at cork and using the word cells. We have Leeuwenhoek. Yes, he's the tooth gunk guy. So you can write that down. Tooth gunk. Whoops. It's hard to write on here. And he was actually looking at, you already know, bacteria. Bacteria. And if you can squeeze in the word animalcules, those would be good words to remember about Leeuwenhoek. Okay, and then we have the two S scientists, Schleiden and Schwann. So Schleiden is our plant guy, so I'm just going to circle the word plants. And then Schwann, like swan, so write down the word swan. He is our animal guy. Now, when I say Schleiden is the plant guy, that means he contributed the idea that all plants are made of cells, while Schwann contributed the idea that all animals are made of cells. And then we get to Virchow, our final person, and we think of that word pre-existing. So he disproved and determined that spontaneous generation is not a thing. Cells do not arise out of thin air, but that all cells come from pre-existing cells. Go ahead and pause this if you need to, just so that you can get all of that stuff written down. And then if you are ready, go ahead and move on to the next slide. The sub can give you a couple minutes to work together with the people at your table. I'll go ahead and erase this so we can see. Yep. So take a couple minutes right here, maybe 2 minutes probably should be good for you to talk with the people at your table and fill in these answers in your own note packet, and then you'll go over the answers together. So go ahead and pause. I'll be back with you guys in just a second. Okay, so hopefully you guys had a chance to go over with your group the answers to these questions, and here are the answers. If you just want to confirm that you got these all correct, you have Schleiden for the first one, Virchow for the second, Schwann for the third, then Hook and Leeuwenhoek. Okay, only 2 more slides, but let's go ahead and take a break. Have your sub start those 5 minutes for you, stretch your legs, you guys know what to do. Okay, welcome back. Hopefully you guys had a good break and you're settling back into your chairs. Let's finish out these notes. One more slide for me to talk about, and then you will practice it again with the people at your table. All right, here's another big slide, right? So let's put a big star on this one. Yes, you are responsible for knowing all of the information on here, which is a good amount of stuff. So, this is our, I guess, finale slide, if you want to think of it like that. So this whole section has been all about the cell theory, right? And scientists that study cells or did study cells from the past. And the cell theory that we still believe to be true today is based on all of those older ideas, specifically from these 3 scientists, Schleiden, Schwann, and Virchow. Notice they are the last 3 scientists of that timeline that we discussed together. And although all of the ideas of other scientists that may not have been mentioned and scientists that came before them, I'm sure influenced their thinking, the 3 that really historically get the credit for coming up with the cell theory are going to be Schleiden, Schwann, and Virchow. Okay, so the cell theory it consists of 3 ideas. So the 3 pieces are, number 1, that all organisms are composed of 1 or more cells. We know that to be true, right? We already talked about that. You know that single cell organisms are unicellular. And organisms that have more than one cell are considered multicellular. So that's not a new idea for you guys, right? But it's part of the cell theory that all organisms are composed of one or more cells. The second idea is that the cell is the basic unit of life in all living things. We know that as well. That's one of our 6 characteristics of life, right? That all living things and all organisms are made of cells. And the last one's a little bit newer for us, so that we just talked about today, is that all cells come from, and I think your notes already say it, pre-existing cells, right? And that really came from Virchow, that last tenet of the cell theory. So there you go. The 3 parts of the cell theory, commit those to memory, write them down, practice them, say them over and over, and know that Schleiden, Schwann, and Virchow are the scientists that have been given credit for coming up with that theory. And you may have already started moving on to the next slide because, don't look at the answers, because you already know what all the answers are. Take a minute or two with the people at your table, fill these in just like you did on the last one, and then I will show you the answers here in just a second. So pause the video. All right, maybe you went over the answers or maybe you didn't just yet, but here you go. Let's check your work. The answers to this are, in the first box, cells. Then you have multicellular. Then you have basic unit of life. Then you have pre-existing and you have spontaneous. I'm sure you got them all right. Give yourself 100%. All right, that's all I have for you guys for notes. The rest of this, your sub is going to kind of direct you through. You're going to be doing a Quizlet, hopefully as a whole class. Practice all those concepts together. Make sure you are starting to commit those ideas to memory about the cell theory and all those 5 scientists. You'll take a formative, and then you got some things to do that hopefully you have been so well behaved that your sub lets you move around the room and get a little bit of freedom. Otherwise, they have the complete authority to tell you that you need to do these activities at your seat. So that's kind of based on your behavior. Well, enjoy the rest of class today, and I look forward to seeing you guys when I get back, or come find me in the halls. Have a good rest of your day.